All right, so the main thing I want you to be able to do here is to follow your arrows. So in this case, I'll give you the mechanism, and then I'll ask you for the product. So for example, we have this reaction with ammonia and hydrochloric acid, and then this is the mechanism right here. So go ahead, try to follow this mechanism and predict what the products and their charge is going to be. All right, so if you've done that, let's go ahead and review this. So there's many ways to think about this. One way you might want to think about is what bonds are being formed and what bonds are being broken. So you can see that we have electrons coming from this N to this H, right? So we're going to form an NH bond. And then finally, we see that we have these this arrow starting at this bond here and going onto this chlorine. That means we're going to take the electrons from this bond and put it onto this chlorine, which means that we're going to break this HCl bond. And then if we think about the products here, right, we didn't touch this NH3 really, and now we formed another bond to this H. This nitrogen was neutral, but now it's lost electrons because it's donated its electrons into this bond. So that means that it's going to now have a positive charge. If we next think about this hydrogen has gained electrons from the nitrogen, but then it's also lost electrons from breaking that HCl bond. So it lost some electrons, gained some electrons, so there's no change here. Let's go back right here. This N, right, lost electrons. So it goes from 0 to +1. And then finally, we have this chloride or this chlorine, right? You can think about it was neutral, but now it's gained electrons, right? It's taken all of the electrons from the bond. So now it shall be negatively charged. So it's going to go from 0 to -1. Let's take a look at another example. This time we're going to use our skeletal structures. So think about what these lines means, right? They represent carbons and hydrogens. And then our reaction is simply going to be this. So again, go ahead, pause the video, try to figure out the reaction, and then we'll go through it together. All right, so let's first of all think about what bonds are being formed, what bonds are being broken. We see that we have an arrow starting at this Br and ending up on this carbon. So what we're doing is we're forming a bromine carbon bond. And we don't have any more arrows, so we don't have anything else to show here. So we draw a new bromine carbon bond. And then we think about the charges, right? This carbon right here, it was positive, but now it's gained electrons from that bromine. So it's going to go to being neutral. And then we think about the bromide, it was negatively charged, and now it's formed a bond, it's given up electrons. So now it shall be neutral as well. Let's take a look at another example. Again, go ahead, pause the video, try to predict what's going to happen here. All right, so now we see this arrow starting off at this bond here and then going on to this bromine, right? So we have it starting off on a bond, which means that we're going to break that bond. So we're going to break this carbon bromine bond right here. If we then think about our products here, we have this one right here. And this carbon right here was neutral. Now it's lost electrons because it's donated those bonding electrons to bromine. So now it shall go to being positively charged. Draw that a little better. And then we think about the bromine, right? The bromine has gained electrons from that bond. So it's going to go from being neutral to being negatively charged. And you can see this is just the reverse reaction of the one before. One more example here. All right, so let's take a look at this example and think about what bonds are formed or what bonds are broken. So first off, we can see that we have this carbon attacking this carbon right here. And so we're forming a bond. We're going to form a carbon-carbon bond. And then finally, we see that we have electrons coming from this bond right here onto the oxygen. So that means that we're going to break a carbon-oxygen bond. So let's go ahead and think about our products here. we've broken this bond right here, so that bond is no longer shown. Both of the electrons have gone onto the oxygen, so the oxygen has gained electrons, and so now it has a negative charge. And then down here below, we formed this carbon-carbon bond. If we think about this central carbon here, it has lost electrons from that pi bond, but then it's gained electrons from that cyanide attacking it. And so we've gained and lost, so that cancels out, and we have a neutral charge remaining. And then finally, we think about this carbon right here. This carbon was negative, but now it's donated its electrons to form a carbon-carbon bond. So it goes from being negative to being neutral. And there we have our product. And so overall, what I expect you to be able to do is what we've kind of done in these videos, and there's some more on the work-alongs. So given a mechanism, be able to draw the product, right, including the correct charge, right? And of course, this is only going to come through practice. So definitely get some practice down. It's a little tricky at first, but once it starts to click, it's really not too bad at all. For right now, I don't expect you to be able to predict reactions other than the one that we'll learn in the next video. All you have to be able to do is draw the product when given the mechanism.